so today's lesson, conics. Here's the good news. Conics and conic sections are so much easier than what we've been doing. So the last 3 lessons before we take the final are pretty easy. I think you're going to like conic sections. They're not too bad. Zoe, you never got one. Well, of course you can. Maybe that's right. So, we talked about the circle. So, what we're talking about today are specifically ellipses. So, objective is equations of ellipses. And I will add circles on there too, okay? So for some reason, this particular book doesn't go through the circles. They just assume you already know how to do circles. So before I do anything, I'll just put down the circle. So I'll go standard form of a circle. And that is our x minus h squared plus a y minus k squared equals r squared. That's the standard form of a circle. But we're not going to do much on circles today because this book just assumes you already know how to do circles, which you should. I teach it in Algebra 2. I don't know if you guys remember it, but it's easy, right? So in our circle, we know that the center is the opposite. It's at h, comma k, and our radius is the square root of r squared, whatever that number is. Okay, so we talked about circles. We did circles in our warm-up, right? We had a circle that we graphed, radius at -2, 3, and the radius was 5, right? We did the circle. But now the ellipses are different. So, standard form of an ellipse is x minus h conic squared over a squared. Okay, now a is the length of kind of like of its radius. So a is this length on the x, like its radius. But you can't call it a radius because, you know, it's not a circle, right? And b is this length, okay? So it's called the minor and major axes. Now you have to be careful because if the circle were like this, right, the major axis goes with the y, and the minor goes with the x. So one's bigger than the other. You just know that the x goes with the x, and the y goes with the y. Okay. All right. Now the focus. To find the focus comes from this equation. C squared is like the Pythagorean theorem, but it's not because it's inside. So C is equal to the square root of b squared minus a squared. And sometimes you need to find the focus. And the focus was the push pins, right? The focus was the push pins. You with me? So when you drew your ellipse and you had your 2 push pins, those are the foci, okay? Right? Now, let's take a look at our first example. So example 1, graph x minus 2 conic squared over 25 plus a y plus 3 conic squared over 9 equals 1. Has to equal 1, standard form. So we know the center is at +2, -3. Agreed? So I'm just going to go to my 2, -3. So a squared is 25, therefore a is 5. And that's along the x, isn't it? So I'm going to go from my center, I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? But I'm not going to go up 5, down 5 because it's an ellipse. So my b squared is 9, therefore my b is 3, right? So I'm just going to go up 1, 2, 3, and down 1, 2, 3. And then I should be able to draw in my ellipse. When a comet is in the sky, comet, right? The focus, one focus is the sun. That makes sense? Because it goes around the sun in an elliptical orbit. The other focus, and this is where Massey has to help me explain it, but the other focus on the other side of like our galaxy is an imaginary point somewhere, but the gravitational pull from all the rest of the mass out there acts as the other focus. Does that make sense? Okay. So we have the same thing. Now we've got to find the focus. To find the focus will run along the x. It has to run along the x-axis. You guys agree with that? Because it's my longer axis. If I were going to do this with my push pins, I would have put my push pins here and here and drawn, correct? I mean, I'm not going to put them here and here because I'd get a totally different ellipse, correct? The push pins would have gone here and here. So to find my focus, we've got to find a length. So we've got to find the value of c. So the value of c is equal to the square root of b squared minus a squared, or it's the square root of a squared minus b squared. It's both. And it all depends on this. Super easy. Which equation to use? Doesn't really matter. You want to make sure that you don't get a negative square root. Do you agree with that?
Yes.
So the bigger one always goes first, right? So I'm going to go 25 minus 9, not 9 minus 25, correct? You don't want negative values. So we're going to go find the value of c. We're going to go the square root of 25 minus 9, which is the square root of 16, which is 4, okay? So my focus, let me see if I can get a different color. Yeah, I get a different color. My focus is sitting here. 1, 2, 3, 4. Here's my focus. And 1, 2, 3, 4. Here's my other focus. So we'll call that F1 and F2. All right? What's the coordinate of that focus? Well, let's just count. That's the easiest way to do it. So F1 is at, let's see, 1, 2, 3, 4, 5, 6, negative 3. And F2 is at 1, 2, negative 2, negative 3. Okay? That's the coordinate of my focus. I just counted. I graphed it, right? So 6, negative 3, negative 2, negative 3. That's the coordinate of focus. Okay? Thumbs up. It's pretty easy. Okay, don't you like this much better than trig identities? Yeah. Okay, turn the page. Am I good? Okay, I'll wait for you. Okay, I flip the page. Okay. Now, example 2. What is the equation of the ellipse with vertices at? And it gives us a focus too. Okay, so, all right, so let's see if we can graph this. So we've got negative 3, 3, that's a point here. 5, 1, 2, 3, 4, 5, 3. And a focus at negative 2, negative 7. Negative 2, oh, something's not right about this.
Yeah, what the haystack?
Yeah, and something is not right. I must have copied this wrong. Hold on. I'm going to have to go back and fix my work. Negative 3, 3, 5, 3, negative 2, 3, negative 2, 3. Let's make that a regular 3, 2, 3, and 1, 2, 3, 4. Let's make that a 4, 3. Wow, I'm going to have to fix this for next year. If they let me do another pre-calc. 4, 3, okay? All right. Okay, what I'm missing is the B's, right? I'm missing the B's. I know it goes out. I know the center is probably right about there. You guys agree with the center being right about there?
No.
1, 2, 3, 4. 1, 2, 3, 4.
Okay, never mind.
You guys okay with the center being right there? It's right in the smack dab in the middle. But what I need to know is its height, okay? So I need to find B. I got to find B. Okay, well I've got a formula, right? Flip the page. I've got a formula for finding B. So I've got this c squared is equal to a squared minus b squared, right? And I got that formula from right over here. And what I want to find is b so I know how far up to go and how far down to go. Okay, well, I can do that. C is the focus. 1, 2, 3. So I know C is equal to 3. And 1, 2, 3, 4. A is equal to 4. I just counted them. That's all I did. I just counted, right? So if this is my center, this distance is my focus, it's 3. This distance is my A, which is 4. Okay, and then I'm just going to plug that in to get the value of B. So, okay, I'm going to go my 3 squared equals my 4 squared minus B squared, right? So I'm going to get a 9 equals 16 minus B squared, right? Subtract 16, I'll get 7. But I'll get a negative 7 equals a negative B squared. But that doesn't bother me because I'll get rid of the negatives, right? Get rid of the negatives. And I'll get B squared is equal to 7. Sky, this is going to answer your question. Square root of 7, right? 2.6 maybe? Somebody maybe have a calculator? Can you do it for me? What's square root of 7? What did you get?
2.64.
2.64, okay. So I'm just going to go from here up 1, 2.64 estimate, 1, 2.64 estimate, right? And then I should be able to draw in my ellipse. Okay, now I still need the equation, but the equation is going to be easy. So the equation came from x minus h squared over a squared plus a y minus k squared over b squared equals 1. Sorry, I squeezed it in there. That's my standard form, right? Now all we have to do is put the numbers where they belong. Okay, that's my standard form. So we're going to go an x minus, well, my center is at 1, 3, right? So I'm going to go x minus 1 squared over a squared, or over 16, plus y minus 3 squared over 7, because that's b squared, equals 1. There's my equation. Okay, how am I doing? Okay, last but not least. Thumbs up. It's a lot easier than trig identities. You guys agree? Okay, last but not least. Let's look at the example 3. So first of all, yeah, we talked about the fact that what if it's not in that form, right? And it's not. Somebody messed it up, right? Sky, you and I were talking about what if it doesn't equal 1. It doesn't. Dang it. Somebody messed it up. So what we're going to do is the same thing we do with the circles. Put the x's with the x's, the y's with the y's, and bring the number over for the radius, even though it's not a radius. So we're going to go like this. I'm going to go 4x squared minus 40x. Leave a space, plus a 9y squared plus 36y equals negative 100. Okay, how am I doing? So put the x's with the x's, the y's with the y's. Okay. All right. Now, I need to common factor out this 4. X squared minus 10x. See what I did? I needed it just to be plain old x was a common factor of 4. Okay with that?
Yeah.
And what am I going to common factor here?
9.
Yep. Plus a 9 times a y squared.
Wait, can't you do 9y?
I don't want to. Trust me, because I want to factor. Good question, Zoe. Okay, plus 4y, right? Plus 4y equals negative 100. How am I doing? Okay, now, you ready? Let's do our half squared, okay? Half of this.
5.
5 squared is? Well, it is negative. You're right, negative 5. Yeah, but, and then negative 5 times negative 5 is that?
25.
So let's put a plus 25 here, okay? Okay, don't get tricked. Are you thinking? Boom! I'm off balance. How much am I off balance?
25.
Nope.
Oh.
How much am I off balance? 4 times 25. What? I'm off 4 times 25 because the 4 is sitting right there, isn't it? So how much I really add in?
100.
Yeah, so we better put plus 100 here. Do you see it?
Yeah.
Okay, what's half of 4? 2 squared is plus 4, but I'm off balance by how much? 36. Okay, let's see what we have now. Okay, so I've got a 4 times factor x minus 5, x minus 5. You okay with that? 5 and 5, right? Plus a 9 times a y plus 2, a y plus 2, right? Equals 36. Because these cancel, right? Okay, standard form. Shoot, if I look at standard form, I'm going to turn the page right now. Standard form is, let's see, a squared over and b squared equals 1, right? Standard form. So I've got to make it equal to 1, right? So I've got to make it equal to 1. So I've got to make this equal to 1. So in order to make this number into the number 1, we're going to divide by 36, right? So divide by 36. We divide by 36, divide by 36, divide by 36. Okay, now, we're almost there. Can you reduce 436 into what? 1/9. 1/9. Now I'm going to ignore the 1. You okay with that? Because I want standard form. So I'm going to have a x minus 5 squared over 9 plus what? A y plus 2 squared over 4 equals 1. Awesome! I can do it now. I know where the center is. My center is at 5, negative 2, right? My A is 3 and my B is 2, okay? I don't know my foci yet, but I'm going to figure out what my foci is. Okay, so then I'm going to start graphing this. So 5, negative 2. Let me get a ruler out. Hold on. Okay. One, 2, 3, 4, 5. So there's my center. Okay, now I know that my A is 3. So I'm going to go 1, 2, 3, 1, 2, 3. My B is 2, 1, 2, 1, 2. Okay, and I can graph it. Now the only thing I'd still like to know is what my foci is. How am I doing? Am I doing good? I mean, these are not hard, are they? So the last thing I want is C. Well, I've got a formula where C is equal to the square root of A squared minus B squared. C is the square root of 5, which is about 2.24. There are some numbers I know. I have a sick mind, don't I? It's true. So my foci, let's see, I can find them, is going to be 1, 2.24 right about there, and back 1, 2, 2.24 is there. Dang it. 1, 2, 2.24 is there. So there's F, forget that. That's a mistake. F1, F2. There they are. Okay. All right, what do you think? Not bad? So the homework's not a lot. We don't have hardly any time to do it in class, but that won't kill you to do a little bit of homework for a change, because I think you can do this. I don't think you really need my help to do this. Okay? What do you think? Thumbs up?